time in 9.2 we talked about conditional probability. Now in 9.3 we're going to talk about conditional probability formulas. So here's actually the formula. So before we were just kind of looking at two-way frequency table and seeing what our condition is to limit our sample space, which column are we looking at or which row totals are we looking at, and then picking specifically our B. Okay, well here's actually the formula. So the probability of B with the condition, or given that A is our denominator is always the probability of our condition, right? We're looking at those totals of the columns or totals of the rows, right? So that's always going to be our denominator. But our numerator is both A and B, right? And if they're independent events, if this is an independent event, then we just multiply those two probabilities. Right, so sometimes you're able to look at it, sometimes you actually need this formula to calculate the probability of A and B. Sometimes you can just look at a chart or something and figure out what is both A and B. So our condition comes second in this part, right here, that bar. What follows that is our condition, right? That's going to go in the denominator. That total is going to go in the denominator. And then you look at A and B. So look at those words given that, who is, who, whatever follows that, that's our condition. That's going to go in the denominator. Whatever is in the numerator is going to both be to the right of given that and to the left of given that, or who is, who is. Okay, so let's go ahead and do problem number 1 here using conditional probability. We have a study, effectiveness of a new drug. Half of the volunteers received the drug, the other half received a placebo. What is the probability that a volunteer receiving the drug and getting well is 45%, or the probability of that is 45%. Then here's the question mark, so here's my question. What is the probability that someone is getting well given that, so there's your bar, he received the drug. So this would be my B and this would be my A, right? Receiving the drug would be my A. That would be my A, so that's my denominator. So I want to find the probability of B given that A. And that'd be the probability of A on bottom. So what's the probability of A? Receiving the drug. Right here, half of the volunteers received the drug, so that'd be 0.5. And then my top is probability of not just B, but it's A and B. So that'd be receiving the drug and getting well. Well, that's right here. Receiving the drug and getting well is 45%, or 0.45. So 0.45 divided by 0.5, that's just going to be 99/10, or 0.9, or 90%. Okay, so there you go. Look for the word given that, or who is, and help you figure out what your A is, what your denominator is going to be, and then what's before that would be your B, and then your top is A and B happening. So look for those percentages. So here you go, same kind of thing, except for this one is receiving the placebo and having his or her health improve is 20%. Here's the question: what is the conditional probability of volunteers' health improving given that they receive the placebo? So try to figure that out.